second part of the video. Thank you for tuning in. There'll be a code in just a moment. So I'm going to go ahead and move my face. You don't need to see me. So again, now we're moving on to example 3. Um, and I hope you did reflect. I'm just going to leave that up there for time, but there's the answer to 2B. But when we solve multi-step problems, this is the big meat of today's lesson, right? So when we solve those, we need to expand our thinking here. Multi-step problems, okay? So what I need you guys to think about is really think logically before an answer. Think about like plus and minus, okay? You're putting a amount of stuff into a pot, taking stuff out. Are you going to have more than you need? That's a positive. Or are you going to need more? Is it a negative? Okay, so let's go ahead and get started. And a chef adds, I'm going to magnify this a little bit, adds a half cup of stock to a stew that 5 times. So 5 different times he's going to add a half cup. During this time, he also removes 3/4 of the cup of stew 4 times to serve, right? So we're pouring in, adding, taking out, negative or subtracting. So let's write and simplify an expression to find how much overall amount of stew is increased or decreased. So the first thing we think about is that we have the number of times, so that's 5 times. There's that word clue there. And how much are we going to multiply? That's a parenthesized 1/2, because each time he's doing 1/2. So that is a multiplication operation. And then what does removal of stew mean in mathematics? Yeah, of course, it means subtraction. And then we have the group numbers, right? There were 4 times that he's going to serve or remove 3/4 cup. So that removal over here is part of this equation. So you multiply these two numbers, and then you'll be able to subtract it from how much water or stock, has been added to the pot. So then we go into our algebra, right? So again, for those of you, PEMDAS, right? We're going to use our PEMDAS. That's our parentheses come first in algebra, then our exponents, division, multiplication, and the last thing you do is addition and subtraction. So over here, 5 times 1/2, so we have to simplify that first. And then we have to simplify, and again, I love the use of a squiggly line to separate. So this is a term over here, and this is a term. So 5 times 1/2, I believe, is 5/2. That's a 5, sorry, it looks like a 3. And then 4 times 3/4 would be 12/4, I believe. And so how would we then write that amount? So we have 2.5 subtract 3. So when we get 4 over 1 times 3/4, we can simplify 12/4. 4 times 3 is 12. So 12/4 is equal to 3. Now we can simplify this or subtract. So now we are at a -1/2. So how much did the overall, not how much is left, but how much of the overall stew was increased or decreased? So it's important that we know that there's probably some ingredient still in there, because you couldn't have a -1/2 to end with. You can't have a negative amount of stock as a total, but you can in terms of this question is how much did increase or decrease from the total. And that means if it's -1/2, it actually decreased by 1/2 cup. So again, operation math, multiplication always comes before addition unless it's in parentheses. And then it's important for some of us to understand, some of you may try to subtract the first number in the expression following the minus sign. Remember to circle each product to remind yourself to multiply first and then subtract. And I'll leave that up here so you can see that. And I'm going kind of fast, but you can pause. So I'm going to have you guys try this, these two parts, and do it on your own, but I'll read it aloud and then push pause. So starting over, a chef adds a 1/4 cup of stock to a soup 7 times while it's cooking. So I kind of started this 7 times a fourth, 7 times a fourth cup. During this time, he also removes 1/8 of a cup 3 different times to taste it. Write and simplify an expression to find how much the overall amount of soup either increased or decreased. And then the answer here at the reflect is, how could you solve problem 3A without using multiplication? Please press pause and do the best you can and check back in a moment. All right, I hope you were able to get some work in. So again, we have 7 times a fourth. And again, I'm going to use my squiggly line to separate the terms. Okay, and now I have on this side, I have -3 times 1/8, right? And so from there on, 7 times a fourth gets me 7/4. And then my second part, 3 times 1/8 gets me -3/8. So we're just going to include that negative symbol here. And so we do have some issue with getting common denominators when we subtract. So this would need to be over 8ths. So the equivalent of 7/4 is what? So if we multiplied by 2, I believe that would be 14/8 is the same as 7/4. Now we have enough to subtract. We get 11/8 soup increases and 1 3/8, right? So 1 3/8 the soup increases. Oops, let me get rid of that. And 11/8, if you did your simplification, again, for those that don't remember simplification, the number on top goes in the box. So 11/8 can be written like that. 8 can divide out of 11 one time. That's your whole number. And when you subtract, that's going to be your numerator right there, and the denominator stays the same. So how could we then, for the reflect question, how could we use problem 3A without using multiplication? Well, we could add 1/4 7 times. So 1/4, 2/4, 3/4, 5/4, all the way to 7/4. And then we could subtract 1/8 3 times. So 1/8, 2/8, and then 3/8. That's 3 times the 1/8. And there's your response for the reflect 3B. So as we close, how do you use, again, multi-step problems with rational numbers? Big part is to read the problem carefully and ask yourself, what is it really asking? Translate the phrases into mathematical expressions. Then you use your knowledge of order of operations to simplify rational numbers. Now your code, here we go. Last time on the homework, we did our birthday. So what we're going to do now, 8/29, let's say your birthday was, and ask your parents what day of the week you were born on. For me, I was born on a Wednesday. So you're going to have to do some Google research or ask your parents what day of the week was it that you were born. And since you're here, we'll do number 5 together. So we have -4/8, and we're going to, again, I'm going to use a squiggly line. I'm going to simplify that, then combine it. And then we're going to subtract 3 2/5. In fact, I'm going to just give myself some workspace so I can see it better, have more room to work. Okay, so 4 times 1/8, that's going to be negative. So 4 times 1 is 4, 4/8. Some of you might see that that's a half. And over here, 3 times 2 is 6, 6/5. And that's going to be a subtraction problem. Okay, so we're going to subtract from a negative number. Now we don't have common denominators here, so we got to get common denominators. So 8/8 and 5 can get me to 40ths. And how did I go from 4/8 to 40ths? I must have multiplied by 5. So what I multiply to the bottom, I multiply to the top. 4 times 5 is 20. And on this one, we have to multiply by 8. So 8 times this 5 gets us 40th, and then we'd have to multiply this top number by 8, and that gets me 48. And so what I like to do is when I'm subtracting two negative values, I'm actually going to just pretend I'm adding two negatives. When we add fractions, the denominator stays the same. And so we're going to get a larger negative of negative 68/40. And from that point, you can turn that into an equivalent fraction, a mixed number. So we know it's going to be 1 and something. I'll give you that help. So that's it for today, my friends. Appreciate you listening. Remember to put your code at the top. You can turn this paper in just the homework page into me next Monday. I look forward to seeing you at conferences and talking to you and your folks on Zoom. And then we can get back to work come October. Thanks for everything. Go Ducks. Bye for now.